And a lot of the circuitry here, and also just in general, is going to come from the biasing circuit, which is the whole purpose of that is to make sure that the um, amplifier remains in saturation in the saturation region, because of course that's necessary for it to behave like an amplifier. So the main difficulty from this project mainly revolved around, the using the mathematical aspect of amplifiers and MOSFETs, as well as the theory behind that, to make sure that the whole circuit functioned and that an appropriate gain was achieved. And you could see for achieving the saturation region, we have to, when we have to bias things, that's why this 37 microamp reference current is here. And that's here. So what that's going to do is it's going to act like a current mirror with its the portion it's connected to, based on the equations that we have for saturation. So of course we have an equation where the gate source voltage of a NMOS is a function, or I guess you could say that drain source, sorry, drain current is a function of gate source voltage, but also vice versa. When we're setting this drain current to a static value here, that means that our VGS, our gate source voltage, is um, being predetermined then, which is why we see the saturation behavior. So if we go through this equation, we can see I guess I'll finish this here. Sorry, I do not have a pen, so I'm doing this with a mouse. So see the drain current is equal to 1/2 over the width times the width over the length times the electron mobility times I believe this is the capacitance per unit area. These two variables you could get into a lot more detail, but they're a little outside of the scope here. Times the gate source voltage minus the threshold voltage squared. So as long as these MOSFET parameters are equal, um, and also these two are equal, which they are in this case, we can see that VGS, oh, and the threshold voltage as well. VGS is going to be set to a static value if the drain current is set to a static value. So then when that VGS is a static value, that means this MOSFET is also going to have a static value VGS, which is going to mean that it's going to have the corresponding drain current, which is also going to apply in this side as well. So all of these levels to this amplifier are basically just doing that, where they're just continuously biasing every single MOSFET so that every single MOSFET remains in saturation, so that of course we have the amplifier behavior that we can expect.